All right, here's the video for notes 3-4, exponential growth and decay. So we've learned about exponential functions and we know what they look like, but now we're going to start using the words growth and decay to describe what we know as increasing and decreasing functions. So in an exponential growth, that is the same as basically an increasing exponential function, which we know looks something like this. So growth, we know that that's also increasing, which means an exponential decay situation would be a case where we have a decreasing exponential function. So think what it means to decay. When something decay, it kind of starts to disappear. So this would be a decreasing exponential situation. So there's two different equations that we can use to represent growth and an equation that we can use to represent decay. So the formula that we're going to use for exponential growth looks like this. We're going to use function notation, but we're going to use t for time. So in this case, time would be our x-axis. That's going to be equal to a, which is our starting value, times 1 plus r. So r is the rate of growth or decay to the t power. Okay, and the formula for exponential decay is going to look very similar. It's going to be f of t, which again is just function notation. It's the same thing as y equals a 1, and since we're decreasing, we're going to do minus r to the t power. So just to make sure we know what certain letters mean, when we say a, that is our initial amount. When we say r, that represents the rate of growth or decay, which is in these situations are going to be given to us as a percent. So that's rate of growth or decay. And then t in this formula represents the time, which could be years, month, whatever the problem is, which is our dependent variable. So on our y-axis for both these situations, this is going to be f of t, and same thing with this one, f of t. All right, so because these problems are going to be giving us the rate of growth or decay as percentages, let's just practice converting percentages to decimals and decimals to percentages. So to convert a percentage to a decimal, you basically move the decimal point to the left 2 places. So 15% as a decimal would be 0.15. So basically just move the decimal from in front of the 5 to behind the 1. So 25%, again, we're going to move the decimal over to the left twice. So 0.25. 25% as a decimal would be 0.25. 1% as a decimal would be 1, 2. So we have to be careful here. 1% as a decimal is going to be 0.01. And then 7% as a decimal, we're going to move the decimal over twice. That would be 0.07. The way you can think about it is we're basically dividing by 100. So we move the decimal to the left 2 places. Okay. If we're converting a decimal to a percent, we go in the opposite direction. So we move the decimal to the right 2 places. So this would be 5%. To the right 2 places, this would be 25%. Move the decimal over to the right 2 places, that would be 1%. And to the right 2 places, that would be 75%. So in this case, we go to the right 2 places. So again, we can think of it, we divide by 100, or you can think of it as multiplying by 100. So in these particular problems, we're going to be converting percentages to decimals. So we just need to know we need to move the decimal to the left 2 places. All right, so let's take a look at this first example. So this says you purchase a pair of brand new Air One Jordans for $170. If the shoes stay in pristine condition, they increase in value. So I'm underlining that so we know we're dealing with a growth situation by 50% annually. It says, how long will it take them to reach a value of $600? Okay, so first thing we need to do is we need to write an equation to represent the situation. So I know that because it says increase, I know that this is a growth problem because we know that it's going to increase in value. It's going to look like this if we were to graph it. So if it's a growth problem, we know that the formula that we're going to use is f of t equals one plus r to the t power. Okay, so in this particular problem, the rate that we're going to use is 50%, which as a decimal is 0.50. We know that the starting value or the initial value is going to be the 170, and then times, for writing an equation, we're just going to keep it as t. So the formula for this situation is going to be f of t equals 170 it's going to be 1 plus our rate, which is 0.50 or 0.50 to the t power. So we should fully simplify, meaning we should add the numbers inside the parentheses. So our exponential growth equation is going to be 170 times, so 1 plus 0.5 is just going to be 1.50, 1.5, I'll put 50 to the t power. So here's our exponential growth equation. Then we're going to use that equation to answer the question, how long will it take them to reach a value of $600? So we want to know, what does t have to be for this to be $600? So in order to figure that out, we're just going to plug in values for t. So this is where we're going to use basically what we learned about plugging in numbers in the table. So I'm going to start by plugging in 1. So when we plug in 1, we get 170, 1.50 to the first power. So now we're going to look at our equation or our calculator here. So 170, 1.50, and then to the first power, we get $255. So that basically means after 1 year, the value of our sneakers are going to be $255. So now let's plug in 2. So it's going to be the same thing, 170 plus 1.50 to the second power. So here we can just change the value to 2. So we get 382.50. Now we're going to plug in 3. So 1.70, 150 to the third power. So we're getting close, 573. So 573.75. So we want to know when it gets to $600. So now let's plug in 4. So it's going to be 170. Sorry, I don't know why I wrote 1.70. So 170 times 150 to the fourth power. $860. So after 4 years, we have $860 and we'll say 63 cents. So that tells us that how long will it take us to reach that value? Well, that happens somewhere between 3 and 4 years. So I'm going to say the value of the Jordans will reach $600 between 3 and 4 years. We don't know exactly when. When you get into higher level math, you'll be able to figure out the exact moment. But according to, as we're plugging in values, we know it happens somewhere between 3 and 4 years. All right, let's take a look at another example. So it says you bought your first car used for $2,000. Each year, your car decreases in value by 10%. How many years will it take your car to be worth only $800? Okay, so I know that this is a decay problem because it says the word decreases. So I know that for an exponential decay problem, my formula looks like this: f of t equals a1 minus the rate to the t power. Okay, so let's first start with the value of a. So the value of a is going to be 2,000. So my formula is going to be f of t equals 2,000 is our starting value. It's going to be 1 minus the rate. So the rate in this case is 10%. Well, 10% written as a decimal is 0.10 to the t power. Okay, so now let's just simplify everything, meaning simplify our parentheses. So f of t equals 200. 1 minus 0.10. If we need to, we can do that in our calculator. 1 minus 0.10 is 0.9. Oops. Okay, I don't know what happened, but everything got deleted, so I had to rewrite it. So f of t equals, it's going to be 2,000. 1 minus 0.10 is 0.9 to the t power. So here is our equation for our exponential decay. So now we need to figure out how many years will it take for your car to be worth only 800. So for the sake of time, I'm going to tell you that you should probably start at a higher number. Starting at 1 year, it's not going to decay very much. In fact, we can kind of look here and plug in some numbers. So 2,000 times 0.9 to the first power. So our value is only 1,800, and we need it to go down to 800. So if I plug in 2, it's 1,620, 3, 1,458, 4, 1,312, 5. After 5 years, it's worth 1,180, 6, 1,600, or 1,062, 7, 956. So it looks like we're getting close. So let's just write out some work here. So let's plug in starting at f of 7. So when we plug in 7, we get 2,000 times 0.9 to the 7th power. Well, when we plug that in, we got 956.59. So it seems like the next year it would be worth less than 800, but let's just see. So let's plug in 8. So 2,000 times 0.9 to the 8th power. We plug that in, we get 860, so we're close. So 860.93. So now let's plug in 9. That should do it. So 2,000 times 0.9 to the 7th power. Let's see if that makes it, or not to the 7th, sorry, that's to the 9th power. We get 774. So there is the case where it's worth less than 800. So 774.84. So it looks like it reaches 800 somewhere between the 8th and the 9th year. So somewhere between the 8th and the 9th year, our value is 800. So writing that out as a sentence, because word problems should have word answers, we'll say the value of the car is worth $800 sometime between 8 and 9 years. All right, so now let's take a look at one of the homework problems. So number 1 says you invested $600 in a new stock and its value increased by 40% annually. We want to know how many years will it take you to have $2,500. So because I see the word increases, I know that this is going to be a growth problem. And we know that our formula for exponential growth is f of t equals a times 1 plus the rate times t. So let's fill in what we know. We know that our initial amount is $600. Our rate, well, we need to write our rate as a decimal. So 40% as a decimal, we need to move it over 2 places, so 0.40. So it's going to be 1 plus a 0.40 to the t power. So to simplify this, it's going to be f of t is equal to 600. 1 plus 0.40 is going to be 1.40 to the t power. So here's our equation representing the situation. So now we need to figure out when our value is going to reach $2,500. So to do that, we're just going to plug in values. So first I'm going to plug in 1 and see what we have after 1 year. So $600, 1.40 to the first power. We have $840. So now let's plug in 2. So 600, 1.40 to the second power. We have 1176. Now let's plug into the third power. So 600 times 1.40 to the third power. We have 1646.4, so $1,646.04. Now we're going to plug in 4, so we're getting close. Again, we're looking for $2,500, so to the fourth power. We have $2,304.96. So I think the fifth one, we should be over 2,500. Let's just see. So 600, 1.40 to the fifth power. We get $3,226.94. So it looks like we reached this value of 2,500 at some point here. So 2,500 is somewhere between the fourth and the fifth year. So how many years? We're going to say it will take between 4 and 5 years to have $2,500.